Hello, welcome to the fourth video of my video series Programming Microcontrollers. In this video, we will see how to build an Android app using MIT App Inventor. What is MIT App Inventor? MIT App Inventor is a tool for creating mobile apps for Android and iOS quickly and efficiently. You can program it using a visual programming language called Blockly. To use this language, you don't need to memorize all the commands to program the app. Instead, you can program the app using an intuitive visual interface. In this video, we will see how to build an app to control a servo motor using an Arduino via Bluetooth. We will use the app to send commands to the Arduino via the Bluetooth module and then use these commands to control the servo. So let's build the app. To access the MIT App Inventor tool, you have to go to this link and log in using your Google account. After that, we can click on this button to create a new project. Then we need to name the project. I will call it Bluetooth Servo and click on OK. After the project is created successfully, this window will open up. This is the designer window. Here we can design the front end for our app. There is also a blocks window using which we can write the background code for the app. First, we will design the front end for our app. So let's go back to the designer. The designer is divided into different sections. There is a viewer section in the middle and a palette section on the left, which contains all the components that we can use in our app. Then there is a component section on the right, which contains a tree view of our app. From this section, we can view the different components that we have used. Below that, there is a media section using which we can upload audio, video or image files to use in our app. There is also a properties section using which we can edit the different properties of a component. The first thing we need to add is a list picker to enable the user to select the correct Bluetooth module. To add a list picker, we have to drag the list picker component from the palette section into our viewer. Now, I will rename the list picker. To do that, we have to select the list picker in the component section and then click on the rename button. Then we need to input the new name for our list picker, which I will call Bluetooth Picker, and click on OK. Now we can edit the different properties of this list picker. The first property I will edit is the height of the list picker. I will set the height to 60 pixels. So type in 60 and then click OK. Next, I will edit the width of the list picker to fill parent. Next, we need to edit the text for the list picker. I will set the text to select the correct Bluetooth module. We can also change the font size. I will change it to 16 and also make it bold. Next, we need to add a slider which we will use to control the servo. To add a slider, we have to drag the slider component from the palette section into our viewer. Next, I am going to change the name of the slider to servo slider. Now, we can edit the properties of this slider. First, I will change the width to fill parent. Next, we need to change the max value of this slider. This is the value the slider will return when the slider thumb is at the end. We need to set this value to the max rotation angle of our servo, which in our case is 180 degrees. So type 180. Then we need to change the min value of the slider, which is the minimum value the slider will return, and we need to set this value to the minimum rotation angle of the servo, which is 0 degrees. After that, we can change the default thumb position of the slider. I will set it to 90 degrees, which is the default rotation angle of the servo. Next, we need to add a label which shows the current rotation angle of the servo. To do this, we are actually going to use two labels. First, I will drag in a label and set its text to current position. Next, we will add another label which will show the current position of the servo in degrees. So drag in another label, but if you try to position this label next to the previous label, you will see that it goes below the previous label. So to align the second label next to the previous label, we have to use a horizontal arrangement. To find the horizontal arrangement, we have to go to the layout control group in the palette section and drag the horizontal arrangement component into our viewer. Then we can move our labels into this horizontal arrangement. And now you will notice that both the labels are sitting next to each other. We can also edit the properties of this horizontal arrangement. I am going to edit the width of the horizontal arrangement to fill parent and also the horizontal alignment. I will set it to align center, and now our labels are centered. As for the text for the second label, I will set it to 90 degrees, which is the default rotation angle of the servo. I am also going to rename the second label so that it will be easy to manipulate it in the blocks. So select the second label and click on rename. I will call it current pos. Then click OK. Now we need to add another label which shows the current connection status. To do this, we are going to do the same thing as before, which is to use two labels. First, I will drag in a horizontal arrangement, and then the first label, I will set its text to connection status. Then I will also change the font size to 18. Next, I will drag in the second label. And as for the text, I will set it to not connected. change the font size to 18 and the text color to red. Then I will change the width of the horizontal arrangement to fill parent and change the horizontal alignment to center. Then I will change the name of the not connected label to connection status. Now, to create connection between the Android phone and the Bluetooth module, I am going to use a built-in component in MIT App Inventor called Bluetooth Client. To add this component, we have to go to the connectivity control group and drag in the Bluetooth Client component. Since this is a non-visible component, it will appear down here. I will also rename this component to BT Client. Now we can move on to the backend code for the app. So let's go to the blocks window. The blocks window is also divided into different sections. There is a main viewer section in the middle. Then there is a block section on the left. This section contains all the blocks that we can use in our app. The blocks are divided into different categories such as control, logic, math, text, etc. Each of these categories are color coded. For example, the blocks in the control category are color coded yellow, while blocks in the logic category are color coded green. There are also special blocks for specific components such as a list picker or a slider. Below the block section, there is a media section using which we can upload audio, video or image files to use in our app. The first thing we need to do is populate the list picker with all the available Bluetooth devices. To populate the list picker, we have to use the before picking event, which is present in the list picker component. So drag in the Bluetooth picker.beforepicking event into the viewer. To set the elements of the list picker, we can use another function which is present in the list picker component called set Bluetooth picker.elements2. So drag that block inside the before picking event like this. Then we need to set the elements to the available Bluetooth devices. To get the available Bluetooth devices, we can use the BT client dot addresses and names block. So drag that block inside the viewer and attach it to the set Bluetooth picker.elements2 block like this. And now, before the user picks a Bluetooth module, it will populate the Bluetooth picker with the available Bluetooth devices. Next, after the user has picked the correct Bluetooth module, we want to connect to that Bluetooth module. To do that, we can use the Bluetooth picker.afterpicking event. So drag that into the viewer and then we are going to use the BT client.connect block, which is a procedure that takes in the address to connect to, and if the connection is successful, then it will return true, otherwise it will return false. If the connection is successful, we want to set a variable to true. We will later use this variable to set the connection status label. Now, to create a global variable, we have to use the initialize global name to block, and we need to change this name to the name of our variable. I will call it connection status. and we have to pass in one argument, which is the value to which we want to initialize this variable to. Since this is a Boolean variable, we want to go to the logic category and drag in a false block which will set this variable to false. After the user has picked the Bluetooth module, we want to set this connection status variable to the value returned by the btclient.connect procedure. To do that, we can go back to the variables blocks category and then drag in the set block, and from the drop down we need to select our block, which is this one, and we want to set it to the return value of this btclient.connect procedure. So attach this btclient.connect procedure block to the set global connection status to block. We want to connect to the Bluetooth module that the user has picked. To get the Bluetooth module that the user has picked, we can use the Bluetooth picker.selection block. So drag that in and attach it to the btclient.connect block. What this will do is that after the user has picked the Bluetooth module, it will connect to that Bluetooth module, and if the connection is successful, then it will change this connection status variable to true, otherwise it will set it to false. In our designer, we had created a label which shows the current connection status. After we have successfully connected to a Bluetooth module, we want to update this label. To change the text, we have to check if this connection status variable has changed. To do that, we are going to use a clock. This clock will trigger every 1 second. To find the clock, we have to go to the sensors control group and then drag in the clock component. This is also a non-visible component, so it will appear down here. Then I will rename the clock to connection status. Now we can go back to the blocks window and use this clock component. In the blocks window, we need to find the when connection status clock.timer function, which will run every time the timer of the connection status clock fires. When the timer fires, we want to check if the connection status variable is true. If it is true, then we want to change the text of the connection status label to connected, otherwise we have to set the text to not connected. To do that, we are going to use an if-else block that is present in the control category. So drag that block inside the when connection status clock.timer function like this, and for the statement we need to check if the value of the connection status variable is equal to true. To do that, we can use the is equal to block which is present in the math category. Drag this block and connect it to the if statement. We want to check if the value of the connection status is equal to true. To get the value of the connection status variable, we can use the get global connection status block, which will return the value of the connection status variable, and we want to check if it is equal to true. So find the true block which is present in the logic category and attach it inside the is equal to block, and then if the connection status is true, we want to set the text of the connection status label to connected. To do that, we have to use the set connection status dot text to block. This block takes in an argument which is the text we want to set the label to, and the text is a string. So we need to use the string block which is present inside the text category. Drag that block and attach it to the set connection status.text2 block. Then inside this string block we can type in the text that we want to set the label to. I want to set the label to connected, so type in connected. Next I will change the text color of the label. To do that we can use the set connection status.text color 2 block. We can select the required color from the colors category. I will choose the green color and then attach this to the set connection status.text color 2 block like this. Now if the global connection status is true, then it will set the text of the connection status label to connected and also change the text color to green. Now we also want to check if the connection status is false, and if it is false then we need to change the text of the connection status label to not connected and the text color to red. To do that we can use the same blocks that we used previously. So I will duplicate this block and attach it to the else function and set the text to not connected. I will also duplicate the text color block and set the text color to red. Now if the connection status is true, then it will change the text of the connection status label to connected and also change the text color to green. Otherwise it will change the text of the connection status label to not connected and the text color to red. Now when the user drags the slider, we want to send the position of the slider thumb to the Arduino via the Bluetooth module, which we will later use to control the servo. To do that we need to create two new global variables. So drag in the initialize global name 2 block, and the first variable we need to create is a variable to check if the position of the slider has changed. I will call this variable pos changed and initialize it to false. Then we need to create another global variable, and this one is to store the position of the slider thumb. I will call it pos and initialize it to 90. Next, when the user drags the slider, we will change the pos changed variable to true and also set the pos variable to the position of the slider thumb. To do that, we can use the when servo slider.position changed function. Drag that in, and when the position of the slider thumb has changed, we want to set the pos changed variable to true and also set the pos variable to the slider thumb position. The slider thumb may sometimes return a decimal value. So to convert it to an integer value, we can use the round block which is present in the math category. Drag that block and attach it to the set global pos 2 block, and we want to set this to the thumb position. So drag the get thumb position block and attach it to the round block. Now to actually send the position to the Arduino via the Bluetooth module, we will use another clock. Go back to the designer and add another clock, then rename it to slider pos clock. Next, I will change the timer interval of this clock, which is the interval at which the timer will fire. Currently, it is at 1000, which means that it will fire every 1 second. I will change that to 500, which will make the timer fire every 500 milliseconds. Now we can go back to the blocks window, and then when the slider pause clock fires, first we want to check if the global pause changed variable is true. Use another if block, and for the statement we will use the get global pause changed block like this. And if the position of the slider thumb has changed, then we will call the bt client dot send 1 byte number procedure, and here we need to pass in the number which we want to send to the Bluetooth module. We want to send the position of the slider thumb, which is stored in the pause variable. So drag in a get global pause block. Next, we also need to change the value of the current pause label to reflect the current position of the servo. To do that, we can use the set current pause.text2 block, and we have to pass in the text that we want to set this label to. We want to set it to the position of the servo, and that position is stored in the position variable. So use the get global position block again and attach it to this set current pause.text2 block. And the final thing we need to do is to set the pause changed variable back to false. We can do that using the set global pause changed to false. So what this will do is that when the timer fires every 500 milliseconds, it will check if the pause changed variable is true. If it is true, then it will send a 1 byte number to the Bluetooth module, and the number is the position of the slider thumb. Then we will set the text of the current pause label to the position of the servo. And finally, we are changing the pause changed variable back to false. So this is all for the backend code for our app. Now we can build the app and install it on our phone. To build the app, you have to go to the build drop-down and then select the Android app.apk option. This will generate an APK file which you can install on your phone. We have to wait for it to compile our app. And after it has compiled the app, it will show you two options. Either you can download the APK file, or you can scan a QR code on your phone, then download it from there and install it. So that is all for this video. Thanks for watching.